All the samples that we collected from below 1,000 meters contained measurable hydrocarbons, as I anticipated they would. We don't have the absolute concentrations yet, but the lab that did these analyses is the same lab that ran the Pelican Cruise samples and a few other oil cruise related samples, and I believe our samples are the only ones that they've had to dilute in order to quantify the hydrocarbon content. So that gives you an idea of how high the hydrocarbon concentrations were. We received last week a couple of additional shipments of samples from 2 other cruises that have happened in the past 2 weeks. One was on the Walton Smith. Those came in. It was a loop eddy cruise, and we'll be doing methane and oil measurements in those samples. And the other were off the coast of Alabama from Mobile Bay to about 50 meters water depth offshore, and there is an anaerobic water body, an anoxic water body, pretty shallow, moving up towards the coast of Mobile Bay. So we're very curious to see what those samples look like in terms of microbial activity and methane concentration measurements. So otherwise, we're basically continuing to analyze the samples that we collected on the cruise, and we're gearing up for our next cruise, which leaves around August 15th. And that's a 5-week cruise that'll be going from the Texas coast across the spill site to the coast of Florida. So with that, I will take any questions that you might have.
Dr. Joye, last week we talked about how the oxygen levels in the water are decreasing. What are you all noticing now? I mean, 7 days later, maybe not that big of a change, but...
Well, the question for those of you on the phone was, have the oxygen concentrations changed in the past week? The answer to that is we don't know. There aren't constant mooring stations out there, so there's not continuous oxygen measurements being made at any of the sites around the spill zone. What people are doing is doing profiles. So you're basically sampling a different body of water every time you do such a profile. The only way to get really good continuous data is to have a mooring out there, and there really aren't any constant measurements being made at depth right now. So that's a problem. The samples that we're working with in the lab, we started an experiment last week. We haven't sampled it this week yet, so we don't know how the oxygen respiration rates have changed in that experiment, but we should have we may have the first set of numbers by next week. But you know, if the rates of metabolism that we talked about last week are continuing out there, oxygen concentrations are certainly going to continue to decrease in the plumes.
When you talk about that is going, I don't know anything about this, the anoxic water body moving toward the water bay, Mobile Bay. What is that?
So over the past month or so, Monty Graham and his colleagues at Dauphin Island Sea Lab in Alabama they've been doing a transect off Mobile Bay for years. They run this transect every week, and over the past month or so, they've noticed a dramatic decrease in oxygen concentrations that they've never really seen before. And the suspicion is that this is some impact related to the oil spill. That's far from definitive at this point, but we're getting they've increased their monitoring frequency because of the oil spill, and we're going to be doing some samples looking at methane concentrations and oil concentrations and respiration rates in those samples to see if in fact it is something related to the oil spill. It's colder water than is usual out there, so that means it's deeper sourced. It's not the water that's usually in that area, and the oxygen concentrations are basically approaching zero.
It's cold water?
It's cold water, so it's from deeper depths. So the water typically at that depth is around 20 degrees or so, and it's several degrees colder than that, 17 or so centigrade. So it means it's moved up the slope from a deeper depth. So if you had water that was down here and it moves up the slope, then it would be colder as it moves up the slope. Does that make sense?
Is that movement itself unusual?
No, that's just seasonal upwelling. That's not unusual at all. But the question is this water that's methane rich that's moving up the slope, or is this oil that's sedimenting down from the top of the water and causing problems on the bottom? There is dispersed oil in the water there. They've noticed that. But they haven't really, nobody's measured methane in this area, so we're going to be doing that this week.
What are the dimensions of this anoxic water?
Well, I don't know that they just do one transect perpendicular to the bay. So I don't think they've actually gone on either side of it to see how far it reaches, but it certainly is different from what they've seen in past years, and it's not correlated. It doesn't look to be correlated with a phytoplankton feature. So it doesn't seem like it's a bloom that settled to the bottom and is being metabolized. And the fact that it's colder water than as usual suggests that it's something that was derived from offshore and is moving up the slope. But this is Monty's project, not mine. I'm just doing the methane measurements.
Speaking of methane, Dr. Joye, we talked about the gas levels last week. Tell me what that could be doing for the ozone as well, or just the environment outside of the water.
So the question was what's the impact of the gas fluxes, particularly the methane flux, on the atmospheric chemistry of the region and in general. The gas fluxes coming out of this well are certainly much more elevated above the natural background, as we talked about. It's unclear how much of that gas is getting to the atmosphere and what its effect on atmospheric chemistry will be, if any. It's certainly a lot of gas that's coming from the wellhead. The question really is how much of that is getting out of the water column into the atmosphere. From our data shows that the upper water column, so the 800 meters to the surface, it has higher methane than it normally does, but it's not the highest concentrations are in these plume features that I talked about last week, that 1,000 to 1,300 meter water depth. And when you get above there, the concentrations are 10 to 100 times background, but they're not 1,000 or 10,000 times background. And the air sea fluxes that have been measured, only one group has done that, and that's John Kessler's group at Texas A&M. And most of the places that they visited during their cruise, which was 2 weeks after my cruise, they didn't see tremendous elevations in the methane fluxes. It was, I think, only near the wellhead that they saw substantial air sea increases in the air sea flux. But again, it's most of the gas it looks like most of the gas is being trapped in the deep subsurface instead of being exchanged with the atmosphere. And that's not really a surprise because the gas is going into the water at such a great depth, and it's cold and it's high pressure, so the gas is just as likely to go into solution, if not more so, than to flux to the atmosphere. You can think about it this way. If the gas was coming out in a shallow water column, say 100 feet, most of it would just egress to the atmosphere, just go to the atmosphere pretty quickly because it's mixed in that layer. But when you introduce gas deep below the surface of the ocean, you've got a substantial capacity for solution of the gas into the seawater. And that gas is once it gets into the seawater, it's the only fate really is to be oxidized by microorganisms. It would take the time it takes to be oxidized by microorganisms is less than they would take to flux it to the atmosphere, because the transfer from the sea bottom of the water column to the surface of the water is very, very slow relative to the oxidation rate by microbes.
How is that sort of transfer into the atmosphere? How is that affected by bad weather in the area? We've had tropical storms moving through there, possibility of hurricanes. What will that do in terms of dispersing that into the atmosphere? Sure.
The question for those of you on the phone is what will the impact of weather be for air-sea gas exchange? Certainly it'll elevate it. The gas exchange with the atmosphere is basically a function of simply put, it's the mixing rate of the water column, how effectively you can piston or push the gas out of the water.